Hello once again. Welcome to my other video tutorial. This time we are going to talk about engineering mechanics, and we are now going to discuss a problem regarding friction. So you have here, as you can see in the figure that I already have drawn, we have two blocks. Okay, one block is block A, the other block is block B. Block A weighs about 160 Newton, while block B is 40 Newton. So block A, weighing 160 Newton, is resting on top of block B. This block A is also tied to a horizontal string which is attached to the wall at point C. Then the block B, which weighs about 40 Newton, is on top of the surface of the plane surface, supporting also block A. And this block B again is weighing about 40 Newton. So there are two coefficients of friction which were given. So the friction between block A and block B, coefficient of friction between block A and block B is 1/4. Remember that if there are two contacting surfaces, definitely there will be friction that is created. So if you have block A and block B, block A on top of block B, the friction is created, then definitely you will need coefficient of friction. And that is given in the problem. So the coefficient of friction between block A and block B is 1/4. While between block B and the plane surface, because block B is in contact with the plane surface is represented by the crosshatch, and the given coefficient of friction between block B and the surface is 1/3. So there are three questions which we have to answer in this particular problem. The first question is, what is this horizontal force P, which is essential to move block B? Okay, so this force P is given the direction going to the right. Okay, and what we need to do is to determine what is the value of this particular horizontal force. That is the first question. The next question is, what is the tension at the string attached to the wall C? So remember, since the string is attached to the wall C and it is connected to the block A, whenever block A would move or whenever there is a motion in block A, tension is created in the string. So what we need to do is to determine the value of that particular tension force. Okay, so that is the second question. Then the last question is, what is the friction force between block B and the surface? So remember that block A and block B is in contact with one another. So that means we can represent F sub 1 as the force created or the frictional force created between block A and block B. While the block B is also uh, in contact with the plane surface. So that means we need to determine the frictional force created between block B and the plane surface, and that is F sub 2. So what we are going to do now is to draw first the free body diagram. So that's the first thing that we have to do. There are two blocks, block A and block B. If you are going to draw the free body diagram for block A, remember that you need to identify all the given forces or the applied forces. So in block A, here, we have here 160 Newton. That 160 Newton is the weight of block A. Remember that the weight is always applied downward relative to the surface. Okay, so you have block A. At block A, we have 160 Newton, which is the weight. Then, of course, remember that we have a normal force. So that normal force is always perpendicular to the surface. So if this is the surface, that is the normal force n sub 1, which is always perpendicular. So that is why we have here the n sub 1. And that particular n sub 1, if you would notice by simply observing the figure or the free body diagram, if you would notice, you just simply take summation of forces vertical is equals to 0. N sub 1 is definitely equals to 160 Newton. So that is why I have indicated here that N sub 1 is equals to 160 Newton. Then let's go to block B. We need to identify all the forces applied to block B. So aside from the weight of block B, which is 40 Newton, which is always applied downward, because block A is connected or in contact with block B, then definitely it will be carrying also, or it will be supporting also the weight or the weight of the block A, which is also the normal force of 160 Newton. So this one is 160 Newton, this one is 40 Newton. Then according to the problem, this is a force P. There is a force P which is applied to block B. That is the one in the question, which is our first question. And aside from that, because block A is connected, or I mean in contact with block B, there is a frictional force created. Okay. Remember, you have F sub 1, which is the frictional force created between block A and B. And then, of course, you have the tension, which is the tension created between block A and the string, that we have F sub 1 here. And then, of course, you have the normal force for block B. Remember that the normal force for block B is always applied perpendicular to the plane surface. So we have here perpendicular to the plane surface, that is N sub 2. And the last force that we have is the frictional force for block B, between block B and the plane surface. Block B is in contact with the plane surface, so definitely aside from F sub 1, there is F sub 2 created. So let us begin with solving for the first question. Okay, so the first question is, we are going to determine the horizontal force P, which is essential to move block B. So how do we move block B? We need a value for the horizontal force P. So let us determine the horizontal force P. Okay, so let me identify, that is our first question, the horizontal force P. Okay. So for the formula, remember that the formula for friction is simply the coefficient of friction multiplied by the normal force. So that was taken from the formula of coefficient of friction, which is equals to F over N, wherein F is the frictional force, mu is the coefficient of friction, and N is the normal force. So if we are going to talk about the first block, because the one in question is the force P essential to move the force P, we need to determine first what are the forces applied to both blocks, so block A and block B. So let us begin with the first block. So let us represent the frictional force F sub 1 for block A as F sub 1, and then the normal force, which is N sub 1. So F sub 1 is simply equals to the coefficient of friction. Remember, we are talking about block A and block B, which is in contact with one another. So the coefficient of friction that we are going to use is 1/4. And then, of course, the normal force here is the 160 Newton. Again, as I have said, the 160 Newton was taken from taking summation of force vertical using the free body diagram 1. or the free body diagram for block A, then you would have 160 Newton times 1/4. F sub 1 is simply equals to 40 Newton. So that means if you are going to look for N sub 2, N sub 2 is simply equals to, okay, 40 plus 60. Okay? 40 plus 60. 40 plus 60. From free body diagram, the second free body diagram. Looking at the free body diagram, the second free body diagram, you would have 40 Newton plus 60 Newton. So that is N sub 2, which is equals to 200 Newton. Okay? And because you have the 200 Newton there as N sub 2, we can now proceed to the determination of F sub 2. F sub 2 is equals to mu. This time, we are going to talk about the block B. So the coefficient of friction which we are going to use is the coefficient of friction between block B and the plane surface. And then, of course, you multiply it by N sub 2. So we are now talking about block B. So F sub 2 is simply equals to 1/3. And then you multiply it by N sub 2, which is 200 Newton. F sub 2 is equals to, we have 66.67 Newton. And that value of 66.67 Newton will be used to determine the value of force P. Using the free body diagram, the second free body diagram. By the way, para hindi kayo, for us to be, not to be confused, this free body diagram is a free body diagram for the first one, or for block A. Then this one is the computation, are the computations using the free body diagram for the second block or block B. So let me continue. Once you have the value for F sub 2, using this free body diagram, the second free body diagram, you just take summation of force horizontal. If you take summation of force horizontal is equals to 0, take note that P is equals to F sub 2 plus F sub 1. And you have P, which is equals to 66.67 plus F sub 1, which is equals to 40 Newton. So P is equals to 106.67 Newton. And this will be our answer for the first question. And then for the second question, we have the tension at the string. So tension at the string is simply equals to, tension is equals to F sub 1. So tension is equals to F sub 1, which is 40 Newton. Okay, you have here the tension using the free body diagram, FBD1. So FBD free body diagram for block 1. And then for the third question, which is the friction force between block B and the surface. Okay, so the friction force between block B and surface is simply equals to F sub 2, which is equals to 66.67 Newton. So these are our answers to the question. Again, to recap, our answer for the force P, which is 106.67 Newton, we have force P, that is the force essential to move the block B. So that means once you have applied a force P of 106.67, it will be able to move block B. While the tension at the string is 40 Newton and the friction between block B and the surface is 66.67 Newton. So that would be all for today. That's our video tutorial regarding friction. I shall see you in my next video tutorial. By the way, again, this is Dr. Ramela B. Ramirez. Thank you very much for listening and for watching. See you again on my next vlog.